Hi friends, today we will discuss about some concept of the lesson thermal properties of matter part 1. First of all, we have to understand the term temperature. Temperature is the degree of hotness or coldness. The temperature is defined in many scales, that is Celsius scale, Kelvin scale and Fahrenheit scale. For the Celsius scale, the lower fixing point is 0 degree Celsius and upper fixing point is 100 degree Celsius. And for the Kelvin scale is 273.15 Kelvin, 373.15 Kelvin. And for Fahrenheit scale, 32 degree Fahrenheit and 212 degree Fahrenheit. There is one formula to convert the temperature of one scale to another scale. That is scale that is given temperature minus lower fixing point divided by difference of upper fixing point and lower fixing point. For example, we have to convert the 20 degrees Celsius to Kelvin. The method is, first we have to write the given scale, that is 27 degrees Celsius, minus lower fixing point for the Celsius scale is 0 divided by difference of the lower and upper fixing point. The upper fixing point for the Celsius scale is 100 minus lower fixing point of the Celsius scale is 0 equal to x. That is we have to find out the 27 degrees Celsius equal to how many Kelvin. That is, we have written it as x minus lower fixing point of the Kelvin is 273.15, and for the difference between the upper fixing and lower fixing point of the Kelvin cycle is also 100, that is 373.15 minus 273.15. On solving this, we will get the answer. There are certain laws of the thermal properties. First law is the Boyle's law, that is pressure and the product of the pressure and volume is constant at the constant temperature, and the Charles law is temperature is directly proportional to the volume given pressure is constant. And the ideal gas equation is, that is PV is equal to nRT, where P is the pressure, V is the volume, N is the number of mole given, and R is the universal gas constant given by 8.314 joule per mole per Kelvin, and T is the temperature. In the many methods are given to find out the temperature of the given surrounding, that we have measure the length of that thermometer or volume of that or resistance of that thermometer. On finding those values, we can find out the temperature at that of the surrounding. T is the temperature at given instant. Xt minus x naught divided by x100 minus x0, where x is a length, volume, resistance, pressure, which we have to find, where xt is the length of that liquid at given temperature T, and at given temperature 0 degree, at given temperature 100 degree Celsius, and at given temperature 0 we have to find, and we difference this thing. Next, thermal expansion. This is alpha, which is a coefficient of the linear expansion, beta coefficient of aerial expansion or coefficient of superficial expansion, whereas gamma is a coefficient of volumetric expansion. Alpha is given by delta L by L into delta T, where delta T is a difference in temperature, difference in length, and given initial length. This is also delta A by A into delta T, delta V by V into delta T, where A is the area, V is the volume, D is the density. The relation between alpha, beta, gamma is alpha equal to beta by 2, 15 plus gamma by 3. That is beta equal to 2 alpha, gamma equal to 3 alpha, or gamma equal to 3 by 2 beta. On seeing the applications by using this thermal expansion, if delta L is the constant at all the temperature, that is delta L becomes same and for different two material, that is alpha 1 and alpha 2. L1 alpha 1 is equal to L2 alpha 2, that is L alpha become constant. If in the question given delta L equal to x, then L1 and L2 are equal to L1 minus, that is difference in length, equal to x, that is L2 equal to x plus L1. And putting this value in this formula, we will get L1 equal to alpha 2 by difference in alpha into x, that is given that, and L2 equal to alpha 1 divided by difference of alpha into x. On seeing the biometallic strip, which is made up of the two metals, if alpha 1 be the coefficient of linear expansion of the first strip and alpha 2 be the coefficient of the linear expansion of the second strip, L0 is the initial length and D is the separation between this distance. That if we heat this and expanding it become the bent shape, and they inclined at theta with the center. That theta angle will given by the L naught, that is initial length, divided by delta r, means r2 minus r1 into delta alpha, means difference in the alpha of the linear expansion of the two bimetallic strips, into temperature at which we have heated. And the mean radius, that is r1 plus r2 by 2, is given by the d, where d is a separation, d by delta alpha into t, where d also given by d, this is also given by r1 minus r2. This formula will help. This shape is the concave, this shape is the convex. Here alpha is directly proportional to the delta L, that means more is the length increases, more is the alpha. We have seen that convex shape is the one which length is increased, so alpha 1, that is alpha 1 is greater than alpha 2. And comparing the alpha 1 alpha 2, the upper strip bent more than the lower strip, so more is the alpha, more is the delta L, that is the more is the elongation, so alpha 1, that is the convex side, is greater than alpha 2. Change in time period of the simple pendulum is another application of the thermal expansion, where change in the time is given by alpha delta t into t, where t is the time seconds of the 24 hours, which is given by 86,400 seconds. Total overall formula is delta t, that is the change in time period equal to alpha delta t. It may increase or it may decrease according to the given question as given in the temperature. And for thermal stress which arises between the which arises for the rod which is kept between the two walls, is given by force per unit area, that is pressure equal to y alpha delta t, where alpha is the coefficient of the linear expansion and y is the Young's modulus. Next we come to the heat transfers, that is conduction, convection, radiation. There are three types of heat transfers. In conduction and convection there is requirement of the material medium, then where for the radiation there is no require for the material medium. First we came to the conduction. Between heat current, that is I equal to change in energy by time taken, which is equal to Ka delta theta by L, where L is length of the conductor, A is the area of the conductor, delta T is the change in temperature, and K will be the coefficient of thermal conductivity. The SI unit of K is joule per meter per second per Kelvin. It can also be written by joule per second means watt per meter per Kelvin. Since I is equal to Q by T, that implies change in temperature by L by Ka. This change in temperature L by Ka, that is delta T by R, where R is a thermal resistance given by L by Ka.